So exponents and square roots is the last part for us to do in this section on sine numbers and stuff. Somebody tell me what an exponent is. The little number up there. Okay. All right, we can work with that. The little number up there. What does that little number up there mean? Okay. So we'll just say x to the n. Okay? Whatever x is, whatever n is. All right, those are two numbers. So x, would you rather me make it a true number? All right. How about we go with 3 to the fourth? Is that better? Does that look better for you? All right. So this thing here, the 3, that's called my base. All right. And this is my power, or my exponent. All right. And what it's saying is how many times do I multiply the base by itself? Okay. That's the question that an exponent is asking. Now, the most common mistake is people look at that and go, oh, it's 12. No. No. Okay, it's not the base times the power. So in this case, if I have 3 to the fourth, that is the same as 3 times 3 times 3 times 3. Okay, I multiply 3 4 times. All right, so it's going to be way bigger than 12. Now, the way I like to do these is here. What's 3 times 3? 9. What's 3 times 9? 27. What's 27 times 3? 81? All right, it's going to be 81. All right, so therefore, 3 to the fourth would be 81. That's how exponents work. Okay? It's basically this number, the bottom number, times itself this many times, the exponent. Okay? So a couple little tricky things about this. One, if you're using a calculator like these type, all right, a lot of times you would just want to put the x squared button, and that would be if your power is 2, okay? Anything that would be 3 plus, you would want to use the caret button. Okay, it's actually right above the x squared on these calculators. So you would use the caret button to put that into a calculator. Okay, you could do it by hand, or you could punch them in the calculator like this. Now, what happens if I have a negative number? Okay, so what happens if I have negative 2 squared? 4. Yeah, because this would be negative 2 times negative 2, which is going to be positive 4. Now, here's one little thing to be careful about. Right here, negative 2 in parentheses squared is positive 4. Negative 2 squared, it's not in parentheses. Okay, so this is an operator now. It's not included with the number. This would just be the 2 squared. Here, this is in parentheses, so you're squaring the negative 2. Here, this is not in parentheses, so all you're doing is squaring the 2. So in this case, that would be negative 4. You guys see the difference there? The first one, this is including the negative with the parentheses. Here, it's not including it. So just be careful with that. Questions so far? Anybody? All right. I'm going to put a couple up here. I want you guys to try them. Okay, there's 4 problems up there. Take a couple minutes and simplify them. All right, you can phone in. All right, so 3 to the third's what? 27. 2 to the fourth is what? 16. 5 to the fourth is 625. Are you sure? Yeah. 5 squared is 25. To the third would be 125. How did I get 500? To the fourth would be 625. Yeah. All right, and the last one. Now, this is a negative. It's to the third. It's going to be, yeah, the 3 to the third is 27. Now, think about it. We have a negative, negative, negative. Yep, so the first 2 would knock it out, right? And then the third one brings it back. So it would be negative 27, correct. Any questions on that so far? I'm not sure. All right, so now roots. Let's talk about square roots. So a square root is basically, it's the opposite of a square. It's the opposite of a square. Square root is the opposite of a square, not the shape. So if I have 6 squared is what? What's 6 times 6? 36. What's the square root of 36? See how they're opposites? All right, so a root asks what number times itself equals what's inside. All right, so that's the question a root asks. What number times itself is equal to what's inside? Now, these are ugly quite often. Okay, you have some things that are called perfect squares, which we'll talk about those here in a second. You have perfect squares. If it's not a perfect square, it's going to come out ugly. So let's talk about the perfect squares. Why does this keep scrolling, jumping down? Oh my gosh. All right. So perfect squares. Correct. Yep. So we're going to call them x and x squared. So basically, I'm going to do the first 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. So if you have x squared, you have a square, you're going to go down. If you have a square root, you're going to go up. Show you what that means in a second. So what's 1 squared? 1. 2 squared. 3 squared. 4 squared. 5 squared. 6. 7. 8. 9. 10. 11. 12. 144. Okay? So these are this is my little perfect square chart. So basically, if I have any numbers on the top and I want to square it, it's going to be the bottom number on the bottom. If I have any of these bottom numbers inside a square root, my answer is the top. So for instance, what's the square root of 64? 8. What's the square root of 121? 11. All right. Square root of 64 is 8. Square root of 121 is 11. Now you can also use these to estimate. If they ask you to estimate, you can say something is between, just say I give you the number 70. Is 70 on our perfect square chart? No, but 70 would fall in here, right? So if I have the square root of 70, that's going to be somewhere between 8 and 9. It's going to be 8 point something. So if you want an exact answer, you punch in the calculator. If you want an estimate, you'd say between 8 and 9. Okay? As you get better at these, you can see that square root of 70 is going to probably be about 8.3, 8.4. Somebody try that. Check that real quick.
Square root of what?
Square root of 70. Say 8.3, 8.4. Probably close to 8.4.
My calculator's being dumb.
What's that?
8.3666.
8.366. So that would round to 8.4. Okay. And all I was able to do is I just used it. I was able to look at those numbers. All right, 70 is a little closer to 64 than 80, just kind of doing proportions. Okay, but that's how you could use it. Questions? Anybody? All right, that's basically it. Just remember order of operations. I think there's a little bit of that kind of stuff on here. Remember order of operations. What's the order of operations? What is it? PEMDAS, yep. All right, PEMDAS. Please excuse my dear Aunt Sally, either one. It's going to be parentheses. Exponents, roots and exponents are the same step. Okay, multiplication, division, addition, subtraction. These go together, these go together. This would be exponents and roots. All right? Any questions?